check that out.
Suppose, if you would, that we could find a formula, maybe this one. Don't worry, this is completely hypothetical. You're not going to have to use this formula. But this was a formula that we could put in some x value. Maybe we'll say we put in the day of the week. So on Monday, Sunday, Monday, we'd put in 2 because it was the second day of the week. And if we calculated it, maybe even using our calculator, it would give us the pick 4 number for tomorrow, the winning number.
Oh, yes.
And you could take that number and you could bet it and make a lot of money. That would be great. As opposed to, what if I put in a number, same number, and it gave me
What a chip.
a bunch of numbers, a bunch of winning numbers. Well, only one wins. So that wouldn't, I hope you appreciate, wouldn't be as useful because I wouldn't know which one to bet on. What if we had another formula, say, similar looking, doesn't matter what it is, okay, once again, completely hypothetical. And this formula, if I put in various x values, say I put in the day of the month, maybe it was the 5th of the month, okay, and if I put in that day, somehow it would magically tell me tomorrow's
You'd like that, wouldn't you?
tomorrow's market closing for the Dow Jones. Well, that would be really nice because then if I knew it was going up, I'd put money in and make money, and if I knew it was going down, I'd of course take money out so I wouldn't lose any money in my stock market. Okay? Well, consider that as opposed to putting a number in and it giving me
Yoink.
2 closing prices. Well, one went up, one went down. That's really of no use to me, I hope you appreciate, because I only want one. I need to know the right answer. I need to know what's going on. If I have more than one, I don't know which one to use. So, I hope you appreciate a formula is really going to be way more useful if it only returns one answer. Well, there's a type of relation that's going to be much more useful than the others.
Well, isn't that special?
It's a special relation called a function.
Wait a minute.
The definition of a function and what makes it special is every element in the domain is paired with a unique element in the range. In other words, every element in the domain gets only one element in the range. Saying that another way, every x is paired with only one y.
His brain is gone.
If you still have trouble, we say, as long as all the x's are different, okay? The deal is that there's going to be some sort of a formula, typically in a relation, that maps every x to a y, that gives every input variable x an answer y. Now, if any of those x's have more than one answer, well, it's not going to make it a very useful formula because you won't know which answer to use. So we're going to limit our practical relations to functions. And these are the ones that, if you would, have only one answer. Or, as I said, every element in the domain, the x's, is paired with only one element in the range, the y's. Let's look at some examples.
Allow me to demonstrate.
For instance, relation A. Is every x mapped to only one y? Or are all the x's different? And son of a gun, they are. All the x's, 4, 0, 6, and 2, they are all different. Now, 2 of them are mapped to the number 6. 4 is mapped to 6, and 2 is mapped to 6. But each of those elements, 4 and 2, is only mapped to one number. So as long as it's only mapped to one number, in other words, each x only has one answer, then you do have a function. So, relation A gets the function seal of approval. Now, let's look at relation B. All the x's are different. That's probably the easiest way to do it, isn't it? No x is paired with more than one y. So once again, we have a function here, a relation that is a special type of function, a special type of relation, a function. In C,
Wait a minute.
all the x's are not different. In fact, in this case, they're really not different. They're all the same. The number 1 gets mapped to various answers. 1 gets mapped to 4, 1 gets mapped to 3.
Yes.
And it only takes one repeat to mess it up. So this, while this is a relation,
Nothing for you.
it is not a function. Finally, D, this is a little bit confusing. D is a relation that has all the x's are different. 4, 3, 2, and 5. They're all different. Now, they all get mapped to the same number,
Giddy up.
but they don't get mapped to, no one gets mapped to more than one y. So, believe it or not, relation D is in fact a function. Note once again, the y's do not have to be different. It's the x's that have to be different. Not fair, isn't it? But that's the way it works. Every x gets only one y, or every input has only one answer, if you would. Now,
Prepare to be astonished.
consider that these pairings can actually be xy points. If we look at the picture of a relation, we can test whether that relation is a function graphically.
Excuse me, Professor Brainiac.
We can test visually whether each x has more than one y by using
Are you pondering what I'm pondering?
what we call the vertical line test. If we run a vertical line test across the graph and it never touches more than one point at one time, in other words, if we move a vertical line across the graph without hitting that actual green graph in 2 places ever, then, and you see, then in fact, we do have a function, and in this case we do have a picture of a function. No x got mapped with more than one y. It is a function.
Do that again.
Let's see if this relation is a function using the vertical line test. It went a little quickly, but it never hit 2 at the same time. So that function is, that relation is a function. Now, just when you thought all relations were functions,
Thank you, sir. May I have another?
let's take a look at this one and see what would make something not be a function. There, in that spot, it actually hit, okay, hopefully you can see, 2 points for the same x value. That's the x value 2, and 2, hopefully you can see, got mapped to about 1 and about 5. So 2 got mapped to 2 things, and of course the vertical line hit the picture in 2 places at the same time. So while this is a relation,
So they said.
it's not a function. How about this relation? Well, does it ever hit the green line in 2 spots at the same time? It doesn't, so that it is a function.
There's something screwy around here.
Now this relation, if we use the vertical line test, hits it in 2 places at that spot. And it only takes one double touch to mess it up. Now there are many other double touches here, aren't there? But it only takes one to mess it up. So while this may be a picture of a relation, it is not a picture of a function.
Nothing for you.
Do you recognize this relation? Maybe you don't, but
Excuse me, Professor Brainiac.
this is a picture of the sine function. Why do you think it's called the sine function? Because it is, in fact, a function. No x gets mapped to more than one y.
But now you know the rest of the story.
Once again, I need you to remember that a function is a special type of relation where every x gets mapped to only one y. So every input that you put into maybe some formula, that formula is such that it only comes out with one answer for each of the x's. So,
Well, goodbye. And don't think it hasn't been a little slice of heaven, 'cause it hasn't.
go do your homework.